Hi everyone, thank you for joining today's session. We have another exciting webinar on a very interesting topic on how to build Agentic UX, and it is around how to build AI native interfaces. I am Rishabh. I am an applied scientist here at Future AGI, where we are building an evaluation and observability platform for Gen AI applications. So I've been in the AI evaluation space for a while now, right from the times when we were deploying traditional ML models to a time where we are deploying LLM-based agents that are also allowed to take certain actions, process information, and present that information to the user. So very exciting times. Today, I'm very happy to be on the other side of the table and host Tyler for this webinar. Tyler is a founding engineer at Copilot Kit and a part of the open source team behind AGUI protocol for agent user interaction. Tyler is through and through an open source engineer with experience at Oracle and Red Hat, working across distributed systems and AI native interfaces. He's been right at the boundary of how humans and AI agents collaborate in real product. And today he's going to share that perspective with us. Thank you for joining us today, Tyler.
Hey everyone, glad to be here.
Awesome. So I'll start with setting up some context for the problem so that people can just appreciate the problem a bit more. As I said, a lot of these companies and developers today are building multi-agentic applications, and the way you can imagine it as there is some LLM in the background. On top of that, you have built specialized agents which can do several different tasks. These agents can be exposed to either the internet or certain tools via APIs. They can have access to internal knowledge bases as well. They can process that information and also take certain actions for the user depending on the query, right? Now, what developers often do is use an orchestration framework just to get that communication between different agents and the different tools that are being used in this entire application. So this could be something like LangChain, Crew AI, and there are many other orchestration frameworks that exist. But what these orchestration framework does is also they provide a layer of abstraction. Now we speak to developers on a daily basis. They have built out an agentic application, and where they struggle is that they do not know where their application is not performing well because they're not getting the desired output from the application, right? Or they're not getting the right action that it is supposed to take. Now, because of the abstraction layer that we have, it is very difficult for the developers to exactly pinpoint where things are going wrong. And here I would like to go back to a very popular abstraction example that is often used in computer science. It is much like the human body or a car, where you have an abstraction layer. And for example, if you fall sick, you do not know internally what's going wrong. And you would see a doctor, they would give several tests and or maybe do an x-ray, and based on that they'll diagnose and then suggest certain fixes. So what we often suggest to developers as well is to have that level of x-ray in your abstraction layer in your orchestration frameworks, so that you know internally each and everything where things are going wrong and where those improvements can be done, so that the right actions or the right output is achieved. And this would look something like this, where you have the entire trace of your agentic application. You know at each level what is the input, what is the output. You have certain system level metrics such as the latency, the cost that the LLM is taking, what was the input for the internal tool calls, whether the right parameters were extracted and fed to them, or there was a problem at the planning stage itself, right? So there are so many moving internal parts that you need to have a complete understanding of where things are going wrong, and that starts with observability layer, which is where you can identify the common patterns between the problems that you're facing across your application. So, what businesses today need to build and run AI reliably? Firstly, during the development phase, you need to iteratively evaluate your application. That, of course, we do in many ways, such as getting human annotations, or maybe some developers also do a vibe check at this point, and based on that, they'll make certain improvements in their system and then roll it out for production. What we suggest to users is to simulate thousands and hundreds of different edge cases for your agentic application. So imagine you have maybe built a financial chatbot, but somebody asks it for a medical advice. Do you know how your financial chatbot responds to that medical question? Because ideally, it is not supposed to respond, or you do not want your financial chatbot to give an incorrect answer to the user or an incorrect medical advice, because that can be very harmful. So, you want to simulate such sort of different edge cases and even the simplest cases possible as well, so that you know where your agentic applications are performing wrong. Then in production, you want to have an observability layer that we have already discussed, have an evaluation on top of it, and then continuously optimize your agentic application based on how users are using that application or experiencing that particular application. Right. And of course, this is currently done with human iterations. There are a lot of human annotations involved. Or if you're setting something as an LLM as a judge, that itself takes a lot of time to set up. And based on that, you diagnose and then fix those problems. Or you could use a platform like ours, such as Future AGI, where this is provided right out of the box. You can simulate thousands and hundreds of different edge cases for your agentic applications. You can have that observability layer that we talked about earlier, and you can use our state-of-the-art evaluation models to get these evaluations for your agentic frameworks as well. Now, when we were speaking to developers, we also realized that developers are often not aware of what sort of metrics should they be tracking, behavioral metrics should they be tracking for their agentic applications. So if they want to measure whether their application is hallucinating or not, what are the metrics that are most important or most important indicators to measure any sort of hallucinations in their agentic application? So for this, a couple of months back, we launched Agent Compass. This is our zero config evaluation setup, where if you set up observability on our platform, we have developed a rich taxonomy of evaluations that runs out of the box for your agentic frameworks, and you do not have to set up any sort of evaluations. So over time, we have developed this taxonomy of evaluations that we believe are the most important for your application to be industry ready. So we run these out of the box for your agentic application, and on top of that, we do clustering on at span level so that you can see at which span your agent is failing. And based on that, we also recommend fixes for your agentic applications. Now, suppose you have done all of this, you have built the best agentic framework and the best agentic application that is out there, very robust. But how do users experience it and how do users interact with your agentic application? Right. So, for example, when you're doing a deep research on ChatGPT, it'll ask you a couple of questions, and then you can see the line of research that it is doing in the background. You can stop that, make some suggestions, make some edit, and build on top of that. Or if you have used Cursor for coding, you could also like interact with that agent. The agent can suggest certain fixes, and you can allow it to take that action, or it can take that action autonomously. So that is where the user experience part of once you have built the agentic application comes in, and that becomes very important because that is how the end level user is going to experience your entire platform. Right, and that is where Copilot Kit and AGUI comes in, where they have simplified this entire framework on how users interact with your agentic applications. So without any delay, I would like to hand it over to Tyler, and I'm super excited to hear his thoughts and learnings while building this.
Cool. Hey, everyone. So I'm Tyler. I'm Tyler Slayton. I am a founding engineer at Copilot Kits, and I am thinking a lot about the agentic experience with my team over here. I want to talk a little bit about what Copilot Kit is, and then I want to get into building agentic applications. So what is Copilot Kit? Well, Copilot Kit is a framework for building AI copilots, which are using user-facing agentic applications. It's open source. We're at about 30,000 GitHub stars and about 200,000 weekly installs, and that continues to grow week over week. We work with companies like the Fortune 100s, unicorns, and startups, and really everyone in between. And we're used by 10% of the Fortune 500s. We're also the company behind the AGY protocol, which is the fastest growing TypeScript AI framework that exists. So, quick agenda, what we're going to go through today. We've already gone through the introduction. I want to talk a little bit about the state of Agentic UI, talk about AGUI, Agentic UI patterns, and then talk a little bit about what's on the horizon. So let's get into the state of agentic UI. Right now, we know every single application is becoming agentic. And at Copilot Kit, we have a really great place where we can interact with a lot of different people building different things. And from that volume, we've really seen two types of applications that people are building. One is a SaaS Copilot, or something like HubSpot, where you have a complex SaaS application that you want to make simpler to navigate through a chat-based interface. And another is a productivity Copilot, where you actually get core work done with it. So let's take a look at both. A great example, like I mentioned, of a SaaS Copilot is actually the Breeze Assistant inside of HubSpot. So in HubSpot, you can go and click on the assistant button on the top right, and you can ask Breeze anything about your specific CRM, for example, like sales data, deals, that sort of thing. Example of a productivity Copilot would be an application like Cursor, where Cursor has the ability to go do core work with you, but you're actually collaborating with it, right? This is increasing your productivity, your core work. So there's one challenge with these applications in that they're really hard and really complex to build. So one really key challenge, and for some reason my image is loading. There it goes. Okay, great. So agents really break the typical request and response paradigm that we've worked with for the last 30 years of the internet. The last 30 years, you would ask for a request and you'd get a response in a timely manner. But agents kind of break this paradigm where you actually will get a stream of events. They're long running, right? So if you go and ask V0 to go build some application for you, it'll do that over the course of a minute or so. And it needs to look responsive, and it needs to have structured and unstructured inputs and outputs. So for example, the structured output might be the data that it's actually writing, the code that it's rendering. But unstructured might be the actual text response that it's giving back to you. Requires composition. So something like multi-agent systems that you were talking about earlier, Rishav, those are also really important to factor in. And it also factors into the UX of that, right? So if you have some long-running agent that is a sub-agent, that sub-agent also needs to communicate its progress back up, right? So it's like nested sets of events at this point. They're also non-deterministic, and they can build non-deterministic UI, right? So this adds a lot of complexity when we're building these applications. So what can we do? Well, what we can do is we can use something like the AGUI protocol, which is the Agent User Interaction Protocol. So it's for connecting agentic backends to agentic front ends. If we take one step back before we actually dive into what AGUI is, let's look at the current protocol ecosystem. So we have MCP. What is MCP? It's the Model Context Protocol. This is for giving your model context. This context can be in the form of tools that it goes and executes. And this is actually one of the main use cases that we see MCP used for today, is giving agents the ability to go do specific things. Like, for example, the linear MCP server or the GitHub MCP server, where the agent can use these tools to get context and actually perform operations. It's essentially like an API that's standardized for every agent, right? Along with this, something that's a little bit less talked about with MCP is things like prompts or resources that you can also provide, which are also different types of context, right? And then A2A, what is A2A? Well, it's agent to agent. This is agent to agent communication. So this is kind of an inherently different concern for MCP, where MCP is really for model primitives, tools, prompts, resources. Agents are really two agents communicating. And what are the concerns there? And that's really what the A2A protocol is concerned about. And AGUI is the agent user interaction protocol, right? So we have how a model gets context and can go do things. We have how an agent can communicate with another agent. AGUI is how we communicate with our users. So like I said, if we combine these two things together, AGUI and Copilot Kit, what is Copilot Kit? Well, Copilot Kit is how you can build applications on top of the AGUI protocol. It is a React consumer, and now Angular, we're going to be releasing that soon, consumer of AGUI events. Again, AGUI is an event-based protocol for connecting agentic backends and agentic frontends. We'll talk a little bit more about that. And Copilot Kit is the consumer of AGUI. But first, I want to show you some of our partners in the ecosystem. So first came the agent frameworks. So we supported and interacted with most of the agent frameworks across the ecosystem. These are companies like LangChain and Mostra, if you've heard of them. Then we integrated with the Google ADK. This was a couple of weeks ago, where now the Google ADK team can now emit AGUI events, and you can use that with any of the AGUI clients, which we'll get to. And this week, actually, or it might have been last week, it's actually last Wednesday, we released the Microsoft Agent Framework integration, and we actually showed up on the Ignite show floor. And we also showed up at .NET Conf as well. And really, AGUI's had a really powerful reception. You might have heard me earlier mention that it's the fastest growing TypeScript AI framework ever, from 0 to 160,000 installs, and this continues to grow. So this might even be inaccurate already. But from that, that's a 5-month timeline of growth from 0 to 10,000 GitHub stars and 151,000 weekly installs. We've had great reception from across the entire ecosystem. So let's talk a little bit about how it works, right? So it is a set of 16 standard events for agent and user communication. So on the right-hand side here, can everyone see the right-hand side with these streams? Great. So to make sure that's good size for everyone. So you'll see this stream of events. I want you to keep that in mind and look at that as I talk. So it's a set of 16 standard events for agent and user communication. It's transport lists. We have default clients with HTTP, but we also support things like WebSockets and WebRTC. And it's a client server architecture where the client is your user, where your user exists, like a mobile app, like a React application, like a web application. And the server is actually your agents. And what are agents? Well, agents are boxes around LLMs. So you can kind of think of them as an analogy or an abstraction of models and how we interact with them. So if we look at the stream, let's really dissect it a little bit. We can see a couple of things. First, we see all these different integrations, and they're split into two: AGUI middlewares and AGUI servers. AGUI middlewares are where an agent has an existing communication protocol that we translate to AGUI. Why do you want to do that? Because then you get access to all of our clients. So for example, on the top there, you see that we funnel through an AGUI client, which then funnels to something like Go or Kotlin or Copilot Kit, which is our React client. Also, we have an Angular client now that's going to be coming out soon. And you can also ship to something like Svelte, for example. So it's platform, it's language and framework agnostic. And then if we look at the stream and really dissect it, you'll see there's a run started event where we can have a run ID, which is maybe a turn of the agents, as well as a thread ID, which is a collection of turns of the agents. Then we have a text message start event. Then we start to stream the deltas of that. And then we get a text message end to denote that this has ended. And then a run finished to denote that the run is finished. So with that in mind, let's just keep all that context and start to think about agentic UI design patterns. So the first thing that I want to talk about is generative UI. And really this comes into three forms. There's static, open, and declarative. So let's look at each, starting with static. So what is static generative UI? Well, static generative UI is where you map generated data from an AI agent or model to existing components on the front end. So since tool calls are structured pieces of outputs, and now that models can also do structured outputs, we can map this data to components to build novel interfaces. Like for example, and this is a pretty classic example at this point of static generative UI, getting the weather in a certain city. It gives you really great deep control over the UI that's generated by your agents. So you can like pixel accurate control what the UI looks like. You can, in this case, I hand coded all of this to look great, but the data, like for example, 38 degrees Fahrenheit, the time, the location, the little icon in the top right, all of that was actually sent to me by the agents. And one target could be tool calls, but it could also be agentic state, just structured outputs that map to a component. So let's look at some code. On the left-hand side is a fake agent framework that I made just for the sake of example. And on the right-hand side is some React code that I wrote with our new V2 interfaces that we'll be launching soon in Copilot Kit. So on the left-hand side, I want to zoom in on a couple things. First is get weather. That's a new tool that we bind into our agent construct on line 6 and line 8. So we define the agent on line 6, we bind in that tool on line 8. So now our agent can call the get weather tool. And then we call agent.agui.serve, which allows us to serve this as an AGUI server. On the right-hand side, we have two things really going on. We have a Copilot chat, which is one of our pre-built components, which I'll show you guys here in a little bit. And then we have use render tool. What does use render tool do? Well, use render tool allows you to bind a renderer or just a component in React to that weather tool. So in this case, we call on line 9 the get weather tool, and we render it with the component on line 11 for the weather card, where we pass in the arguments of the location as well as the result.temperature. Then finally, at the end, we return a Copilot chat component, which is one of our pre-built components you can utilize. So all of that together looks something like this, where keeping in mind the code of what our UI looks like on the left side here, we can get a chat interface that looks something like this, where you ask it what the weather in New York City is, a tool gets called by the agents, and then I render the results of that tool to the UI, static generative UI. You can also do this in a headless way, where behind the scenes, that Copilot chat component is doing a lot of heavy lifting. But if we just wanted to see what those messages are, we could dissect them like this. Agent.messages.map. Each message would have content and might have some UI, which we render here. So there's some pros and cons to this. The pros is that it's really simple. It's really simple to visualize and understand. It gives you full control over your UI, so your designers are very happy because you have great pixel accuracy. And it's great for the common paths that your application tends to take. But there are some cons. The first is that there's some high coupling between your front end and your back end. Your front end needs to be aware of the tools that are rendered that can be rendered from your agent, right? So there's some high coupling there where the awareness of both the tools that are available as well as the schemas need to be determined by the client and the consumer. And this also means that your code base grows linearly with use cases. As you add more and more components, you will have more and more code you have to write. So let's talk about some other alternatives that are emerging in the ecosystem. One of the brand new ones and really emergent ones that we have yet to see in the wild, but is really starting to be adopted or really starting to be experimented with is open-ended generative UI. This is where the agent returns a fully open-ended piece of content that can be rendered inside of UI. And this is typically from an iframe, where you have something like MCP UI that will return an iframe that you render in your UI and can be interacted with to do interesting pieces of interaction with your user. So in this case, we have an iframe where we might render something from a web sandbox, and then we have a URL for our application. What this lets us do is have our application interact with the iframe and bidirectionally. And this is actually what the Chat GPT Apps SDK is doing, if you've seen that released recently. So there are some pros and cons to this. The pros, great. Now we have low coupling between the front and the back end. The agent could just emit some UI that we render in our chat or in our interface, and we can truly render anything now. That anything can be fully generated by an LLM, something like V0, or it could be something that's partially generated, that's static, but it's still sent through an iframe. There's a couple of cons though. So the UI may vary unpredictably. Since your agent has complete control over this, the agent is really the end all be all of your styling and your theming and things like that. So common use cases tend to suffer, right? It's also really difficult to style. Famously, it's really hard to style a nested iframe. And there are some security and performance concerns with rendering a bunch of iframes. For example, if you're building a web-first experience, this looks great, but it's really hard to port that to a native environment where a DOM won't exist, where you would typically render an iframe. So there's a bit of a middle ground between these two, and that's actually declarative UI, where declarative UI is a semi-open set of constrained UIs that can be driven by a declarative spec. It's a lot of words, so let's break it down. If you think of JSON, right? JSON can take schemas, and you can pass type-safe schemas so that when you define some JSON, you know exactly what you're rendering. This is great because we can leverage this exact same thing to give an agent a schema of components that it can use to build some generative UI that it wants for us. It's somewhere in between, like I said, static and open-ended generative UI, and it's typically described by cards and widgets or in recurrent elements like forms or inputs or buttons. So altogether, you can get something that looks a little bit like this, where your spec might have a card and then an image, and an image can take a source and a size, and you might have text, which also has a value that you render. And this would be something like your typography library for that text, for example. And if you put it all together here, we see we have a card that has an image at the center, which is an airline logo for Pan Am. And then we have that Pan Am text value for the airline name and number, as well as the departure city and arrival city, where the agent actually specified, this is the order I want this data in, and here's what that data is. And then we just render that in the UI. So there's some pros and cons to this as well. Pros is that there's really low coupling between the front end and back end still. You can accommodate many common use cases with this, and it's extensible to many rendering frameworks like ShadCN or Radix or any UI framework you might want to use. And you will also still have some of that pixel accuracy that you would want. However, there are some things like you need to accommodate fully custom UI needs. If you need to do that, you can't do it anymore because you're constrained by the spec. So for example, if your spec doesn't have a map component, you can't render a map piece because the agent is not aware of how to do that. And similarly to fully open-ended generative UI, the UI may vary unpredictably, so your common use cases may suffer. So for example, what we were looking at earlier, sorry, I went a little far back, maybe in this example, the logo actually got sent to the bottom for whatever reason. So now the logo is at the bottom, but the data is all still there. It's just in different orders, right? It's really up to the agent how it wants to order these things. So with all of this in mind, what does AGUI support? Well, AGUI's whole approach is to embrace, extend, and innovate. So we embrace every standard that emerges, we extend it to make it simple to use, and then we innovate and come up with our own. So for example, an A2A mesh can communicate via AGUI to UI here, where an A2A mesh might send some static generative UI that you render inside of your UI. Or you might have an MCP server that returns something from MCP UI, like an iframe, that AGUI is also able to transport to your UI, that is also able to transport to your UI for rendering. So in this case, we have the agent say, you are absolutely right, AGUI and MCP work great together, and then we render some weather component in here as well. All right, so let's talk a little bit about agent state. This is another AI design pattern, AI UI design pattern. What is it? So agents are typically stateful abstractions of the stateless LLMs. So if you've ever worked with a model provider API, you have to pass in, if you want to get a conversation, all of the past history. So agents are a nice abstraction of this because they do that for us, where we just send the new message that we want, and all of our previous messages are handled for us. And some agent frameworks do this in really interesting ways, like with, for example, with Mostra, they have this concept of semantic recall, where based off of the query, they grab only the relevant messages within a conversation instead of loading them all in. It can be messages, the state, but it also can just be structured data. Something like LangGraph, for example, is able to store structured data that you can then pass into the model for context. This structured data can also be generated, but it doesn't have to be, right? If we make some query to a database, we don't need that to be LLM generated. We can just return that as structured state that we build generative UI on top of. But that state, or grabbing that state, could be determined by an agent. So let's look at an example with the new V2 interfaces and that fake agent framework I made. On the left-hand side here, you see I define a state schema with a name string. And then I pass that state schema to my agent so that when I call that agent, I'm able to, read and write and maybe update that state schema. On the right-hand side here, I'm able to just render that by calling agent.state.name. So now I can see exactly what the name, in this case, I wanted to render the user's name. So as I have a conversation, maybe that state schema updates to include the user's name so that I'm aware of who I'm talking to. But what if we want to write this? And this is where things get interesting. So that state schema, now let's add a counter where we have a counter string that will increment each time that we update. And so on the left-hand side, we pass that state schema again, agui.serve. On the right-hand side, we do something a bit more interesting now where we call agent.setState, which if you're familiar with React, works exactly like reactive state, where I'm actually just setting the agent state value for the counter to be incremented by 1 via a button click. And if we put these two things together, you can actually build something like V0. That's what we call a canvas application. So on the left-hand side here, we have a document string. That document is what we're going to be iterating on between a user and an agent. And I pass that state schema again, but now I have a new tool that I don't define for the sake of brevity. That tool is able to generate a document. So if I ask the agent, hey, write this document like this, it's able to generate that. On the right-hand side, I have a couple of things. One, I have my agent again, but now I have some changes and set changes. This is going to be pending changes from the user. I can render that document, and as the user adds new content to it, I can actually click a button to save those changes so the agent's aware of it as well. So let's take a look at what all of this looks like together. So this is an application that I built for a workshop that we do with Pydantic AI, actually, called the To-Do application. And it's a really simple application that, truthfully, I vibe coded pretty quickly. On the left-hand side here, on the right-hand side is actually Copilot Kit's pre-built components that you can get out of the box that allow you to integrate with your AGUI agents. So behind the scenes, this is connected to an AGUI agent, and we're going to do some interesting things with this. First, I'm going to add a task here, and I'm going to call it do the cool stuff. I'm going to call it foobar bars. And I'm going to move this to in progress. If I ask the agent what the current to-dos it has are, it's going to be fully aware of that. So do the cool stuff, foobar bars, it's also in progress. If I I can also ask it to add a new to-do for building a website, and that gets populated as well. What happened here is that I call a tool called add to-dos, which takes in an argument. In this case, the LLM decided to generate a to-do called build a website, and then it sent me back a state snapshot. This is an AGUI event for states. So the stateful things that we were talking about earlier, this is actually what's happening through the AGUI protocol. In this case, we can see all of the new to-dos that we're setting a state snapshot of. I can also do this concept of front-end tools. And this is this is where things get even more interesting, where you might see that everything turned this nice plum color. So what actually happened there? Well, what happened is I defined a tool on the front end. That tool gets passed through AGUI to my agents. The agent decides to call that tool, but it gets executed on the front end. So what this lets us do is provide agents with DOM manipulation, where the agent can actually update your UI right inside of the UI without having to do any nonsense outside of that. Let's move on to some of the other examples. For example, I can ask it to move the first to do to in progress. So move this done to in progress because that was the first ID. I can also ask it to fully send it. And I want to really zoom in on this. This is a human interaction where I'm about to click something here that'll translate to some action in my UI. The agent said, hey, I want to do this. Are you okay with that? And I can click confirm or cancel. I'm going to click confirm here. And so everything moves over. This is an example of permissions and really just making sure that your agent is doing what your user wants and making sure that the user is guiding your agent. So Copilot Kit is great for building semi-autonomous interactions or collaborative experiences with your agents. And then we can also just ask it to delete everything just so we can kind of get a clean state. And that's an example of what a Canvas application is like. This is kind of like V0. This is kind of like Vanis. It's kind of something where you're collaborating with an agent towards some task. All right, so let's get back to what's on the horizon.
So, Tyler, I have one question for you before we
Yeah.
proceed. So, engineers and designers who are currently, thinking about designing such experiences for agentic applications, what do you think is like how they're currently thinking of designing these experiences, and what sort of perspective shift is required such that they can design better experiences, such as what you showed right now for their users?
I think that there's some really important things to consider. One is that agents are long-running processes, right? So if you don't have great UX, a user's just going to be staring at a loading screen for 30 or 40 seconds. And this is actually a
Right.
very common plague on the current UI UX of the industry is these really cool applications that take 30 or 40 seconds to respond, but return nothing in between. So it looks like they're basically broken, right? If a user is looking at something for more than 10 seconds, they'll start to rage click and think that things are broken. So
Mhm.
there's some really clever things that you can do with streaming, for example. So earlier you might have seen in this example that I am emitting tool calls that are actually happening. So the user knows, oh, I'm getting the to-dos and then I'm deleting the to-dos, right?
Right.
So if I ask it to add in a new to-do, I can also see a tool. I can see that it's getting context and then adding a new one. And if it responds, like for example, I say write a long poem, I can see that stream in instead of it
Mhm.
all being one block of text at the end and I'm staring at a screen, right? So that's one thing is streaming is important. You cannot build an agentic application without something like streaming because otherwise they look like they're broken.
Mhm.
Outside of that, you can do some interesting things around generative UI where you're returning output to a user that looks interesting visually. It looks like it's responsive, but really it's taking the same amount of time, right? That's what's super
Mhm.
interesting about this is that you can build experiences that look generative, that look great, that take a long time, but feel responsive. And that's really what these V0 applications, Cursor, think about what they do, right? They share a lot of common things. Streaming output to a user, streaming, a text component that looks like it's code. So that as the code comes through, it looks like it's writing the code. These are kind of novel things that it does, but they're still long-running processes. They still take 40, 50 seconds to go execute. So I'd say streaming and responding early and often are some of the most important things you can do.
Thanks. Yeah.
Yeah, absolutely. All right, so let's look a little bit on the horizon. So we believe that 2026 is really going to be the year of voice agents. Why? Because voice is extremely intuitive and your conversation can actually continue as work happens. So if you saw earlier there, I send a message, I wait for that message to finish, and then I send another one. Maybe if I built some really great UX, I can also double text where I interrupt that agent and then send a new message as well. What's super great about voice, though, is that you can have this pattern where the voice agent is your interaction modality, but the agent is actually going and doing stuff that voice modality is observing, but not being interrupted by, right? So if I ask a voice agent to go search the internet for pizza, and it takes 40 seconds, and I can't talk to it in that 40 seconds, things look broken. But what's nice is I can actually have a voice agent that just is responsible for conversing and communicating status updates that then goes and kicks off a text-based agent that the voice agent observes. And I think this is really going to unlock voice modality as the default choice for people to interact with applications when they are not in a public setting. I think that's the other thing is text will continue to exist. but voice is a really great way to do core work. I have something called Whisper on my computer where I can transcribe my voice into text that I hit enter on my keyboard. So for example, I can ask it to please add a to do for getting pizza later today. And it adds that text right into here. What if the agent could just go do that, right? What if I didn't have to go hit enter and the agent just said, great, let me go do that for you, and it responded like it was a conversation. So that's how we see voice modality as panning out in 2026. And why 2026? Because agent frameworks are really starting to adopt voice as a modality that they communicate through via things like WebRTC. We also believe that agent steering is super important and will remain very important. So fully autonomous AI is going to become very difficult without steering. The more autonomous agents become, in fact, the more important we see that mid-run steering actually becomes as well. And then we also see self-improving agents, or what we like to call auto RLHF, or auto reinforcement learning on human feedback. So earlier you saw me hit a button that I clicked that I said approve for the agent, right? That was actually some valuable feedback. That was valuable signal to the agent that it tried to do something and the user accepted it. But this can also be nuanced, right? So if you're Cursor and you go and have an interaction where you generate some code, that code gets committed or saved and then edited, that's also a valuable signal where the agent tried to write something, it was partially right, but got edited. So collaboration with your user is really how you improve agents. It's so important for improving agents, in fact, that Cursor was able to build their own model on the feedback that they were getting from Cursor. So they have the new Composer 1 model, and that's how they built it. And that's really built on user edits, user edits and feedback as signal for a model or for reinforcement training. And it really lets your agent improve automatically over time. And so what are some conclusions that we can derive? One, I think we're all in agreement that agents are becoming real. Agents really also change how we think about UI and UX. Generative UI is a really essential pattern for building generative applications. Voice and modality is going to grow, and it will grow very fast. And auto RLHF will provide agents with learning at scale. So thank you very much. That's been my presentation. From there, Rishav, any questions?
Yeah, so we have a lot of questions in the chat. I'll start asking you some of them.
Great.
Someone has asked, can we fit in the AG UI Copilot in our existing web app as our SaaS is a mix of AI and non-AI? Right now we have UI for all AI, but if we want to replace it with AG UI, is it possible?
Yeah, absolutely. So Copilot Kit comes with pre-built components that just speak Age UI. And if you have a model that you like to use, you can just wire it up to Age UI. We have support through Copilot Kit for thousands of models. Outside of that, if you're using an agent framework, you can also just wire your agent framework up through one of our dozen or so integrations from spanning LangGraph to Microsoft to Google, anything that you might be using. And it's really simple to add into your application. We have React components that are pre-built. We also have fully headless UI if you want to go build your own custom thing. And this is all built on top of the primitives of AGUI.
Awesome. How would this work with LangGraph?
Yeah, so the way that this works with LangGraph is LangGraph will start a server. We then convert those server events and interaction protocols into AGUI so that when you go and consume a client like our Kotlin SDK or React or Angular, you're talking AGUI that you're then able to render inside of your UI. So this provides a couple of interesting things. One, if you're an agent framework, you can now ship to any of the clients on the other side of AGUI. And two, if you're an app builder, you can also swap out your agent framework or build your own agent framework and get all this nice, rich interactivity.
Dave is asking, does Copilot help maintain thread information? For example, if you're having a conversation, then have another conversation, does it let you keep that information in memory, or do you need a backend to store this information?
Yeah. So Copilot Kit does let you do that. Copilot Kit ships with this concept of an agent runner, where we actually store those AGUI events through some generalized storage. It could be MySQL, it could be in memory, it could be Redis, whatever you want to store to. And then when you go to reconnect, you're able to load up those AGUI events into your thread, and we will persist that for you. And you can use that with our runtime. Or if you just want to use, maybe you use an agent framework or a platform like Langsmith, you can also just forward those requests directly to Langsmith through the runner abstraction as well.
And there's a follow-up question to this. So, and what happens to like very long running conversations? How can you like intelligently design UI for long running conversations?
Yeah, so for long running conversations, one is streaming outputs. So if you've ever used something like Claude Code even, where Claude Code is going and doing some long running task, it continually lets you know that it's still alive, right? How does it do that? It sends you messages. It sends you, hey, I'm calling this tool. I'm reading this file. It doesn't need to do that, but it's
Mhm.
telling you that so it looks responsive and looks still alive because the loading screen looks dead. It looks broken. So that's really it. It's just respond early and respond often. So respond as soon as you can and respond as much as you can between the start and the end of the task. And you can use generative UI in the middle. You can use messages. You can use anything you need to communicate the status output of some long running task.
Yeah, and this is something that we have experienced this ourselves. Like users have become very impatient, so they no longer want to look at loading screens. They want to look at outputs, even though if it might be half baked or you might show something like still thinking or making your answer better. But having just that feedback for the user also like makes them a bit more patient and a bit more makes their experience a bit more better
Yeah.
on the
I'm
platform.
going to show one example that I think really enunciates what I'm talking about here. So let me grab that. So this is a travel application that I built as one of the first projects I had with Copilot Kit. So I'm going to ask it. I'm currently in New York, but I want to plan a trip to San Francisco. So plan a trip to San Francisco. And this is going to take 30 or 40 seconds. But as it does that, it looks really responsive. So for example, I just saw that it searched the internet. And now I can see it build a plan. And I can see that plan be constructed here. And I'm actually using a faster model, so it might generate faster than I thought it would. So in this case, it was like 30 seconds. I can click add, and then that updates my UI here. And now we have a trip to San Francisco. That's pretty quick, right? But imagine that took 30, 40, 2 minutes, etc. Streaming makes it seem really responsive, where that probably took 20 seconds, but if it was just a loading screen, it would look a whole lot less impressive, a whole lot less visually interesting if it was just a loading bar and then all the output at once.
Awesome. So next question is how does AGUI or Copilot Kit relate to Versal AI SDK?
Yeah, so Vercel AI SDK is really a vertical stack of interaction for models where you build your agent framework and also consume that exact same agent framework within one vertical stack, right? And that vertical stack can span, languages, or sorry, it can span frameworks like TanStack or Next.js, of course. And really, they're trying to keep you within the entire AI SDK stack. What's great about Copilot Kit and AGI is that Copilot Kit is the horizontal solution to this, where you can use any agent framework you might want to use if you don't want to have to subscribe entirely to the entire AI SDK. If you want to have piecemeal pieces of this, we support the same things, but we support the entire agent ecosystem as opposed to the agent primitive within the new V6 AI SDK that's coming out.
Nice. Joel is asking when will Vue be supported? They've been waiting patiently.
Vue can be used today, technically. So with our new V2 interfaces, we will have a new package, and that package will be called Copilot Kit Core. That Copilot Kit Core package is actually framework agnostic. So you can use it in any framework that you would want to use it in. We just won't have native Vue support in the sense of our components, I would say in the immediate term. But you can use Copilot Kit within your Vue applications and get all these nice abstractions like front end tools and everything that you might want to use. It would just be you would have to go build your components. You just get the headless UI.
Also, personally, this is my question. Tyler, do you also think is it sometimes useful or like does it make the experience better to show the users the internal workings? So, for example, if there is communication happening between two or more agents, do they need to like does it help any at all with the experience, or does the user only care about the end level output that they're receiving?
It's a bit of both. I would say that agent to agent communication or like handoffs and these sorts of things are a little bit less important, but the user still wants to know when it happens because it says, "Oh, I'm like if you said something like I'm consulting or calling the research agent with this input and this output." That's a little bit less interesting. But if I say, "Hey, talking to a research expert," like that's a
Hmm.
little you kind of tweak the language, and now it makes sense. Now I know, okay, I'm waiting for the research expert to finish, as opposed to having to get really granular with the output. Like right here, this whole tool call, there's a lot more data here that I don't show, but I just show you the stuff that's relevant to the user.
So the kind of messaging also that comes with it becomes very important on how you're communicating that to the user.
Right. Yeah, exactly.
Gautami is asking, does this protocol support multi-agent orchestration or parallel message streaming?
Yes to both. So I'm going to show off we have our docs for AgeUI. So if you guys ever want to take a look at this spec, I'm just going to show that off really quickly here. So under the events here, we have a couple of cool events. The first one I want to zoom in on is you asked about multi-agent flows. AgeUI has this primitive called steps inside of it. And what steps are really just steps within either a workflow or a multi-agent system. So in this case, the step name would be maybe your subgraph. If you're doing a lane graph agent and you have some subgraph that gets called. Or if you have an agent mesh, this would be the agent mesh as well, and so on and so forth. And then runs also support that. And then the messages are also scoped to those steps. So if you have multiple agents all executing, they will be scoped to a message that the message can stream from two agents within the same UI.
Awesome. And Parth is asking, what is the biggest mistake you see teams make when they try to add an AI agent into an already existing application?
I think they wait too long for it. I think they go and they build their agents and then they want to bolt that agent onto some UI, but they haven't considered any of the UI or the UX of that application. They've just gone and built an agent that works in a bubble. And now they want to apply that to some UI and UX that feels cohesive. But 9 times out of 10, it's really hard to do that from the beginning. There are some things that you can do where you make the agent aware of through front end tools, for example, what's happening on the UI, which makes it a little bit easier, a little bit less painstaking to connect with all of your backend systems and then connect that to your UI. But actually, Copilot Kit really helps solve this problem where if you've built an agent, now you just submit it via Age UI, then you can integrate it right into your UI. Makes it a lot easier to do than having to start from scratch.
Prashant is asking, how opinionated is AGUI about how the interface should look versus just defining the event model under the hood?
It's completely unopinionated. We're just defining the event model under the hood. And then Copilot Kit leverages this to give you some default components that look nice to build your applications on top of, as well as some like nice, helpful hooks that make it easier to interact with AGUI in a React and Angular native way.
Mhm. Someone's asking, what is the difference between using Copilot Kit and AGUI protocol and using the AI SDK by Versal?
Yeah, so I mentioned this earlier. Versal, you subscribe to the Versal model router. You have to use the model router with the AI SDK. And then on top of that, you build with the same hooks on top of that. And then on top of that, you build your UI. So Versal doesn't ship with one components. They can map components to certain things like, for example, prompt kit. So can Copilot Kit for what it's worth. But that would be your whole stack. It's very vertical to Vercel. And now that Vercel is also building agents into their SDK, which you can go see with the new V6 blog, they also want you to build your agent framework on top of that vertical, right? So if you ever wanted to write code in Python, for example, you can't do it. You have to use the TypeScript stack, subscribe to that. So if you wanted to write an agent in another language like .NET, for example, with our new .NET SDK from Microsoft, you can't do it. You have to go and build either a translation layer or write some crazy glue code to be able to translate that into Vercel's internal streaming protocol that they don't document. So it's this really vertical walled garden approach. Whereas Copilot Kit and AGUI together are a horizontal one where you can use LangGraph, you can use .NET, so you can use Microsoft Agent Framework or CrewAI or whatever you want to do. And really that's what we're describing.
I think we have discussed around this question a little bit already, but how do you decide what internal reasoning tool calls to expose to the user and what to keep hidden?
Yeah, I mean, it's a good question. I would say it really depends contextually to your application as well as your users. If your users are deeply technical, you want to have deeply technical results. So, like Cloud Code shows you deeply technically or deep technicality into what it's doing. But if I'm doing something like a research assistant, I don't really care what the tool calls are. I just want to know that it's still running, right? And
Mhm.
what is it actually researching? These are different, right? I want to know what it's researching, what the queries are, but I don't really care that it's a tool call. I just care what the query is. So it really depends and is contextualized to your application. I would say that very often it's tuned to how technical is your audience, because AI and tool calls and reasoning, all of these things are pretty, I would say, technical. And very
Mhm.
often reasoning steps are not actually that useful to a user outside of just seeing that things are still executing. I mean, I don't know about you, but I very rarely read the reasoning steps. Really, the reasoning steps are just for the agents to perform better. And it's a lot less for performance or sorry, a lot less for interactivity with my user.
Yeah, I think Gemini or some other models also show their thinking steps, but I've never really looked at it. Only times when I've looked at is when that they've not performed or they've not given me the desired output, and then I try to see what went wrong in the
Yeah, it's like a
reasoning.
good debugger, essentially.
Yeah. Yeah. Dimitar has asked, do you plan to include some out-of-the-box features like voice, document attachment, etc.? Some of them provided by competitors like Chainlit.
Yeah. So AGUI, the protocol itself does support multimodality. You would just pass it along and then you communicate that down to your agent. No problem. File uploads, we have no opinion about that. So you could just, if, with Chainlit, you would have to go start the Chainlit server and then upload to the wherever Chainlit. Well, I haven't used Chainlit before, but I'm assuming it's something like Streamlit where you start the application and then you have to upload to something. And that something's probably either hosted by Streamlit or Chainlit or hosted on your computer. In this case, you have a lot more control. It's just wherever you want that file to get uploaded to, you can upload it to it, and you have complete control over it. And then over the wire, the protocol can transmit things like links or multimodal modality to different models.
Got it. Lior is asking, AGUI seems like a great way to create a protocol between clients and servers. What about a situation where I would want my agent to communicate with multiple clients like Slack and not just my browser app?
Yeah, what's great about this is it's transportless, so you can communicate with whatever you want. And we actually have from the community a Slack client that allows you to go and interact with an agent through Slack. Since AGUI is transportless, anything can emit AGUI, including a Slack server that you have that you store somewhere. It can receive AGUI events from an agent, translate that to Slack events, and that's actually how we do that. So AGUI is really, really flexible for kind of anything that you want to build. For example, we have a Rust maintainer working within the AGI ecosystem. They're actually the owner of the maintainer of the largest Rust framework for AI right now. And they're helping us to build our Rust SDK so you can build things natively inside Rust, right? So that's not necessarily a client that you would normally want to build with, but you can do some interesting things like that with a lot of native type of environments.
Boris is asking, when is Copilot V2 available?
Yeah, so we're going to have if you go to our website right now, at the top of the website is this getting early access right here. Get early access to V50. Inside of V1.50 will be our new V2 interfaces, which will be available via a subpath. So V1.50, if you've been using Copilot Kit, will be improving a lot of the internals, and it'll be backwards compatible. And then all the new hooks will also be backwards compatible. So there will be a new V2 subpath inside of React Core that'll have all of these new V2 interfaces that I was mentioning.
Vinamra is asking, can they contribute to Vue support that's going to come?
Yeah. So someone in our community a long time ago built a Vue integration. I don't know how the maintenance of that has gone, but as we start to get more serious about natively supporting Vue, and by the way, if you want to get started with Vue today, you can use our Copilot Kit core package to do so. But if you want to have those native new components, that'll be something that we would love to have the community be involved with when that comes.
Okay. Can you integrate AGUI with Streamlit UI and LangGraph?
Absolutely, you could. I think that's just not something we've done yet, but that's definitely something you could do. AGI is extremely flexible. You can use it really for whatever you want it to be. Any kind of interaction between an agent, you can use AGI for.
Carlos is asking, how is state management different from LangGraph versus Mastra? Which one is better integrated?
They're both equally integrated. State in LangGraph is a native concept where each node can execute and get state. So as you go through the different nodes, state gets emitted, so on and so forth. And then they use that to build their new LangChain package for agents called Create Agent. For Mastra is a little bit different, where it's the exact same way, except they have this memory primitive and they have structured memory within that. And that's actually their concept of state that we interact with when it comes to things like shared state. So as your structured working memory gets updated by the agents, that gets emitted as state snapshots through the protocol. So the stateful abstraction of Copilot Kit is actually these state snapshot events here, where you can send a state snapshot of any data. You can also send deltas as well over the wire.
Okay. What part of everything you showed is completely open source and can be used for free in my apps?
Every single thing I showed you today is free and open source.
Uh, what do you get with managed service versus open source?
Yeah, so our managed service provides persistence out of the box. So you might have heard earlier, we mentioned threads and things like that. Our managed service provides threads out of the box for any AGI ecosystem agents. So for example, if you have built your own agent framework and it emits AGI, we actually provide threading for that out of the box. You don't have to worry about that if you use our hosted solution. And then we provide product analytics on top of that and all sorts of fun things. Like, for example, we annotate human feedback and things like that. So you're able to see, oh, my agent wrote this and then my user edited to this. And so you can do some interesting things with that data.
Okay, a couple of last questions. How would you handle agents that interact with multiple UI changes or websites, such as analytics agent that can generate Kibana dashboards?
Yeah, it's interesting. So I would say that if you have an agent that's going and generating a Kibana dashboard, probably what you're doing is you're actually building some JSON spec that gets written and can be written to in the back end. AGI is really the interaction protocol, right? So what is the user interactivity that's involved there? Are you having a user say, generate this dashboard for me? Or are you kicking off some job that the user clicks a button for, and then that goes and generates some UI? Really changes the answer, because if you're doing a interaction kind of where you have the user say, I want to generate this UI, then you would have something like AGI and Copilot get together that would allow you to say, hey, generate this UI that looks like XYZ with this spec. Versus if it's a button, you could also use AGI, but you might not use something like Copilot Kit, because Copilot Kit is for interactivity. So if you click off a button and then you want that to go generate something, really just depends on what you want that UX to look like.
Okay. Gautami is asking, how can we access or refer to SDK and documentation, or is it available via GitHub?
Yeah, everything's available via GitHub. So if you're curious about AGI, we have a couple of quick starts here for building applications, integrations, and clients. If you want to learn about Copilot Kit, we have documentation as well as examples. Everything I talked about with generative UI today is available here. You can look into our AGI protocol and learn more. You can also go into our documentation where we have deep reference documentation. So you can view all of the different interfaces I discussed today. You can also go and use our Vibe Coding MCP server to just give your coding agent of choice full context into how to program with Copilot Kit.
And I think we'll also have some of these links sent across after the webinar in an email so that you can access all of them.
Yeah, that's exactly right.
So, so I think we are looking at time. Thank you so much, Tyler. This was an amazing session. I learned a lot about how can we think about better user experiences when designing agentic applications. And thank you everyone for joining the session. I hope that you are taking something away from this webinar and looking forward to the next one. Thanks. Thanks a lot.
Thanks, everyone.